So now that you know quite a bit about completion stage methods, the more advanced features in completable futures, let's talk about the final piece of the puzzle, which are the arbitrary-arity methods. And as you can see from the pie chart here, that's the smallest of the different types of methods that are part of the completable futures interface. There's only 2 of them. So arbitrary-arity methods return futures, or each arbitrary method returns a future that is triggered after the completion of some or all futures passed as parameters. So as you can see, both allOf and anyOf, which are the 2 arbitrary-arity methods, take var args, which basically mean it's sort of like an array or a list of these things, and they return a completable future that when all the other futures complete or any of the other futures complete will cause the returned completable future to complete. Now, these arbitrary-arity methods are very hard to program without using little wrappers. So I wrote a wrapper to make life a lot easier, and we're going to talk about that. But first, let me just explain briefly what these methods do. So if you take a look at arity, that just means number of parameters, number of arguments passed to a method. As you can see here, you can have an arbitrary number of them, because it's basically an array. And the future that comes back can be used to wait for any or all of the n completable futures in the array parameter to complete. We're going to focus on allOf, which is sort of like then combine on steroids. We talked about some of the other stuff. So the except either thing we talked about, that would be sort of a simplified version of anyOf. AnyOf is except either on steroids. allOf is then combine on steroids because you can wait for more than just 2 of things. So that's basically the way it fits into the broader scheme. Here is how we're going to demonstrate this particular capability. So if you recall, we had generated some large number of unreduced big fractions. We'd called map to reduce and multiply all those big fractions asynchronously. So we had a stream of completable futures for all the operations that are being performed in parallel. And then we call collect, and we said futures collector to future. And to future is just a helper method, or it's really a factory method that's going to return a single completable future, which, when all the other futures it's waiting for complete, will then indicate that things are finished, and we can go on to the next stage in the stream in this case. So this collector, the use of collect here with this collector will convert a stream of completable futures into a single completable future that completes when everything in the stream completes. So you'll see in a second what this does. So futures collector is essentially going to be used as a little wrapper for allOf. And you'll see that futures collector converts this stream of completable futures into a single completable future that's triggered when all the futures in the stream complete. And futures collector is a collector, which implements the collector interface. And if you recall, remember, the collector will accumulate input elements into a mutable result container. So hopefully you guys remember what that was from the previous discussions, and you've implemented very, very simple examples of collectors. This is a much more interesting example of a collector. So this provides us an extremely powerful wrapper for what would otherwise be very complicated code. You would not want to have to write this code manually for all your programs because it would be very unwieldy. So we kind of suck it into a little helper class, make a collector out of it, and it becomes much easier to use. So here's how this works. A lot of this will look familiar. So futures collector implements collector, so it implements a custom collector. The type of input element, in other words, what the stream is producing, is a completable future. So we've got a stream of completable futures coming in. The mutable accumulator type, in other words, what is being used inside the collector to keep track of the stream, will be a list of completable futures to type T. And what's returned by the finisher method, what's the output of this whole thing, will be a completable future to a list of T. So we get a completable future which, when it triggers, will yield a list of values of type T that are no longer pending. All their computational processing, that was running asynchronously in parallel has now completed, and we've got it back to what it was before. So let's take a look at the various helper methods here. So here's supplier. Supplier is the factory method that creates and returns a new mutable array list container. So it's actually a factory method that returns a constructor reference that will do all this stuff. So that's what that provides. It gives you back a supplier, which, when called by the framework, will make a new array list. Here's what the accumulator is. It's another factory method that will take a completable future and add it to the internal array list. This method is only ever called in a single thread, so we don't need any locks for this. That's just the way the collector works, because it's going to be a non-concurrent collector, as we'll see in a second. Combiner is used if this were to be called in a parallel stream context in order to be able to merge two partial array lists of completable futures into a single array list of completable futures. So it's only relevant for parallel streams. Once again, it's only called in a single thread, so it doesn't need any locks. And here then is the piece de resistance. This is the finisher method. And what this does is this performs the final transformation from the intermediate array list, which is used to accumulate all the completable futures, to the final completable future result type. So this is just totally crazy. It's really cool. So what happens here is that finisher is going to take the array list of futures, and it's going to go ahead and take that array list of futures, convert it into an array. So now we're going to have an array of completable futures, and it's going to pass that array of completable futures, which corresponds to the array list, to the completable future allOf method. And what that does, that's just allOf, that's just what comes out of the box from the completable future arbitrary-arity method allOf. This will convert the array of futures and return a single future that will complete when all of the completable futures passed to it in this array have completed. In other words, when all the asynchronous processing is done, the future returned from allOf will trigger. So it's giving you a single point to wait reactively for all the other computations to finish. We then take that completable future that came back from allOf, and we apply, or we call the completion stage method then apply. This method only gets called back when the completable future returned from completable future allOf completes. So when that future completes, it's because all of these futures have completed. Then this thing gets triggered, and then it goes ahead and runs the computation here. And what this does is this takes the array list of completable futures, turns it into a stream, and then it goes ahead and joins each completable future in the stream. So before we had a completable future to type T, after calling join, before we have a stream of completable futures of type T, after this map call, we have a stream of completed type T objects, which we then collect into a list. So we have a list of type T, and because then apply returns a completable future, we're going to get back a completable future to a list of completed completable futures. You can see why you would not want to have to write this code yourself. It's very, very subtle, and it takes a while to get all the kinks worked out, but it's super cool, and it fits wonderfully into the broader context of the Java Streams framework. In particular, you can see here that what comes out of collect, because of this futures collector, is a completable future to a list of elements of type T, where those elements are going to be the reduced and multiplied fractions, big fractions. And that completable future will then be handled by then except when all the other computations finish running asynchronously. So then except is only called when the future return from collect completes, and the future return from collect, or the completable future return from collect, only completes when all the completable futures that were running in parallel as a result of this call to map complete. So we're just kind of narrowing things down, and we end up with a single completable future from collect that we can then wait upon. And as we saw before, when that finishes, when everything else is finally done, we will sort and print the list, again, in parallel, but the point is that the end result is getting a printed list of reduced and multiplied big fractions. Any questions about that? So your assignment number 4 will be doing stuff like this. Not this, obviously, because you're not dealing with big fractions, but you're dealing with images. And so you will have code in assignment number 4 that looks sort of like this. And the main difference between assignment number 4 that you do and what I'm showing you here is that assignment number 4 that you write will actually use a futures stream collector. So futures collector, as shown here, will return a completable future to a list of, in this case, big fractions. What you're going to do in your program is you're going to use a different future collector called futures stream collector. And futures stream collector is going to return a completable future to a stream of, in your case, I think they're images. So it's even cooler, and it makes a lot of sense when you look at the broader context in which your code is used, where it makes more sense to have a stream in your assignment rather than a list. But the basic logic is almost identical. Just a few other things about this collector. So its characteristics, it's just an unordered collector. It's not going to be concurrent. It's not going to be, it doesn't have a finisher, identity finish method characteristic, just an unordered collector. And here is the toFuture factor method that creates a new futures collector. And this is just following along with the pattern that you see in the collectors utility class, which has factor methods like toList, toSet, toMap, and so on, that are used to make the appropriate type of collector. Okay, any question about this? So that's the end of that discussion. At this point, you should have all the raw material necessary to be able to do assignment number 4. Although I will, again, give you a word of advice, it's a non-trivial assignment. So start early and come to office hours, ask questions, and make sure you really understand it, because it's pretty complicated.